I'm not sure if anyone would find this useful or interesting, but I'm about to make the question that's going to be on our quiz tomorrow. And if there's one thing that I don't like to do, it's to do work that I can only use once. So by making this a little bit trickier just this one time, I might save myself some trouble later. So the idea is that I'm going to have two real zeros. I'm going to call them C and D. And then I'm going to have two complex zeros. And that's going to have to be A plus BI and A minus BI. So as you can see, I've got four different numbers that are going to be going into determining whatever this is. So if the two real zeros are C and D, that means that the two factors will be x minus C and x minus D. And for the complex ones, it'll be x minus A minus BI and x minus A plus BI. Sorry, that was a mistake. So here's the way mathematics generally works. There's loads of examples, but the examples are just illustrations. They're only useful once. I want the rule. I want something that's useful all the time, forever. And so if those are the zeros, those are the factors, and if these are the factors, then I want the polynomial. So I'm going to just expand this whole thing and see what I get. Okay, so x times x is x squared. X times minus d is minus dx minus cx plus cd. Okay, now this I can rewrite as minus c plus dx. There we go. So there's one quadratic, and this one, this one's going to be ugly. I'm going to make a grid for this one. X minus A minus BI. X minus A plus BI, so I guess just BI. Okay, so x squared minus ax minus bix minus ax plus a squared. The negatives cancel, abi, xbi, or I guess bix would be more appropriate, minus abi, and plus b squared. Okay, so what cancels? Bix and minus bix cancel. ABI and minus ABI cancel. So what I am left with is x squared minus 2ax. Huh, no b's. Plus a squared plus b squared. Okay, so now I've got to put those two together. Whew, this is gonna be ugly. All right, so I need a new chart for this one. So 3 across the top. X squared plus, that's plus, right? Oh, no. Minus. Minus, let's put that in the parentheses. C plus D x plus CD, and then down along the edge, x squared minus 2ax plus a squared plus b squared. Okay, well, let's make my grid. Oh boy. X to the fourth. Would be minus 2ax cubed, a squared x squared, b squared x squared, minus c plus d x cubed, cd x squared. Negatives cancel, so 2a c plus d x squared minus 2acdx minus a squared c plus d x plus a squared cd minus b squared c plus dx plus b squared cd. All right. There's only 1/4 power of x here. However, there are 2/3 powers of x. So that would be minus 2ax cubed minus c plus d x cubed. All right, as for the squareds, yikes. So I've got cd x squared plus 2a c plus d x squared plus a squared x squared plus b squared x squared. Man, it's a lot. X to the single power here, I've got all minus. Interesting. Minus 2acdx minus a squared c plus dx minus b squared c plus dx. And then the constant terms plus a squared cd plus b squared cd. Okay, this needs to be simplified. X to the fourth. So if I were to factor out this x to the third, what I'd have is minus 2a plus c plus d x cubed. If I were to take these squared terms and factor out the x squared, I'd have plus cd plus 2a c plus d plus a squared plus b squared. If I were to take these x terms, factor out the x, that would be minus 2acd plus, and now again I can factor out c plus d of a squared plus b squared x plus and then that's just a squared plus b squared cd. Why? Why would any person do this? Well, the reason why is because I've just made every fourth power polynomial with two real and two complex solutions ever. And I will show you. So what I'm going to do is I'm going to open up a different window. I'm going to program this in and make a polynomial. And I'll never have to make another one again. So give me a moment so I can load the screen. Let me see if I can there we go. Move this up. I think I can probably put that here. Actually be easier for me to switch them. Oh, there it is. Okay, so there's the polynomial that I want to make. Okay, so if I make a new sheet, let me see if I can zoom in to make this look a little better. A little easier to see. Oh, it's still catching up. There we go. Yeah. It's a lot easier to see. Too much. Okay. So I've got 4 possible numbers. Oh, excuse me. 4 possible numbers to be as factor into the zeros. So real 0 C, all right, whatever that is, I'll put it there. Real 0 D, whatever that is, I'll put it right there. And now complex real part, I should put A, and then the complex imaginary part B. Okay, so those will be the 4 numbers. Okay, so the way this is going to work is I've got coefficients and variables. So this will be the coefficient for, well, I guess it's just going to be x to the 4th. Actually, you know what? I think I would rather make these a little shorter. So I'm going to put it here. X to the 4th. Now, this is going to be the next number. I'm assuming it's minus. And what is it minus? 2a plus c plus d equals 2a, equals 2 times a plus c plus d. Okay, right now it's 0 because there's nothing in there. And that's going to be x cubed. Add to that a plus. Okay, I don't want a formula here. So there we go. Plus, now this one is CD. Ugh, okay. So equals CD plus 2 times A times parentheses C plus D close parentheses plus A squared plus B squared. Right now it's 0 because there's no numbers in there. And that would be the coefficient of x squared. Okay, next up is a minus. Minus what? 2 times A, C, D plus parentheses C plus D close parentheses times new parentheses A squared plus B squared and see, I don't need to close any more parentheses. Add to that x, and now I can just add the last constant term. That's equal to, in parentheses, A squared plus B squared times the product of C and D. Okay. I think it's time to try it out. So, if I were to, let's just take one that I've solved already. See if I can find some, here's one. Oh, that's a cubic, hold on. I'm gonna find a fourth power polynomial that I solved earlier. Oh, there we go. So this is one of our homework problems here from earlier. Whoops. Just move that out of the way. So the values were 3i, negative 3i, 2, negative 1. So if I put in 2 and negative 1, and for the real part of the complex number that was 0, because the imaginary part is 3. So, according to this calculator thing that I've just made, if I could zoom in on that a bit. A fourth power polynomial that has these 4 zeros should be, let's see, x to the 4th minus x cubed plus 7x squared minus 9x minus 18. Is that what it was? I seem to have... Yep. That was it. X to the 4th minus x cubed plus 7x squared minus 9x minus 18. Now, this is not a problem solver. This is a problem generator. I wonder if I can find any other problem I solved. No, I solved that problem twice. Oh, what was the demo that I did in the video? Let's see if I still have that. No, I don't seem to have that. I only have the cubic in the fourth power that I just solved, which is fine. Oh, wait. Oh, that one was the sample. Okay, well, at least I know it works. So essentially what I can do with this is when I go to make a question, I can just choose what the answer is and it'll make a problem for me. So let's say I want the two real zeros to be -3 and +2, and then the complex zeros can be 1 plus 5i and 1 minus 5i. Ew, okay, see, I don't want to give you that one because that's got 156 at the end. That's ugly. So let me make this 5 plus I and 5. Oh, same problem. All right. Maybe if I put a 5 here and a 2 there. Better. 75 has the factors 1, 3, 25, and 75. Yeah, I can do that. 1, 3, 5, 25, and 75. And as you can see, 3 and 5 are the ones that'll do it. So, let me just, move this out of the way again. So here's how this works. Let's say I want the answers to be -3, 5, and 2 plus I and 2 minus I. Okay? If I want the answers to be that, I need to give you this polynomial, x to the fourth minus 6x cubed. You can see that says plus -2, so minus 2x squared minus -50 would be plus 50x minus 75. All right, so this polynomial should have the answers -3, 5, 2 plus I, and 2 minus I. I wouldn't use something like this without thoroughly testing it. I've tested it once, but I'm going to give it one more shot. I'm going to solve this problem and see if I get those answers. All right, let me just make this gone so I have more room. Okay, so there's the polynomial in question. Now, doing the rational zero test, I would try 1, I would try -1, and then I'd probably try 3 first. -3 would be the first one that I actually get, so let me actually confirm that -3 is a 0. -3 to the fourth power minus 6 times -3 cubed minus 2 times -3 squared plus 50 times -3, 50 times -3 minus 75. So let's see, 3 to the fourth power, it's 81. It's negative, but it's even, so it stays positive. Now minus, see, 3 cubed is 27, but when you multiply that by 6, you get 162. This is minus negative, so plus 162. 3 squared is 9. This would be minus 2 times 9. That's minus 18. 50 times -3 would be minus 150, and then minus 75. Boy, that's a lot. 81 plus 162 minus 18 minus 150 minus 75. 0. Okay, so we've got a 0 confirmed. That part works. Pretty sure that this formula works now, but I just have to keep going. So since negative 3 is a 0, that means x plus 3 is a factor. So I will be dividing x to the 4th minus 6x cubed minus 2x squared plus 50x minus 75. I will be dividing this. So x goes into x to the 4th, x to the 3rd times x to the 3rd times this is x to the 4th plus 3x to the 3rd. Subtracting it out, I've got negative 6 minus 3, that's negative 9x cubed. Okay, bring down that. X goes into negative 9x cubed minus 9x squared times. Okay, so minus 9x squared times this is minus 9x cubed minus 27x squared. Negative 2 minus negative 27 is 25x squared. Bring down the 50x. X goes into 25x squared 25x times. 25x times x is 25x squared, and times 3 is plus 75x. Subtracting these, I've got 50 minus 25. I'm sorry, 75, that's minus 25x. Bring down minus 75. X goes into minus 25x minus 25 times. Minus 25 times x plus 3 is minus 25x minus 75. Now you can barely see there, but those are the same. So we're left with 0. Okay, so according to the way that this is done, I've got to start over with that cubic function. But at this point, I'm basically certain that this works. I'm only finishing it because I said that I would. I want to remind you why I'm doing this. It's because when I give you a problem, I want to guarantee that there is a findable solution. And the way that I can do that is to set up a general case that I can fill in with whatever numbers I want. Okay, so x cubed minus 9x squared plus 25x minus 25. So we've already found negative 3. The other factors of 25 are 1, 5, and 25. Eventually, I would discover that 5 is a 0. That would be, 5 cubed minus 9, 5 squared, plus 25 times 5, minus 25. This would be 125. 9 times 25 is 225. Plus 25 times 5, well, that would be plus 125. And then minus 25. So 125 plus 125 is 250. 225 plus 25 is 250. So yeah, that all balances out. 5 is a 0. Since 5 is a 0, x minus 5 is a factor. Okay. X goes into x cubed, x squared times x minus 5 is x cubed minus 5x squared. Negative 9 minus negative 5 is negative 4. Bring down the 25. X goes into negative x squared, negative 4x times. Negative 4x times x is that plus 20x 25 minus 20 is 5. That's 5x. Bring down minus 25. X goes into 5x 5 times. 5 times x minus 5 is 5x minus 25. It's all gone. So that's the quadratic, all right? We found -3, we found 5, and now we need to use the quadratic on this. I already know what the answer is going to be. This is just too perfect, but I'm going to run it anyway. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. 16 minus 20 is -4, so 4 plus or minus the square root of 4i. That's 4 plus or minus, I'm sorry, should be -4 in there. I'm getting ahead of myself. 2i over 2, so the 2's cancel. I've got 2 plus or minus i. Yeah, that's what we started with. 2 plus i, 2 minus i. Just so we are remembering this. -3 and 5, 2 plus I, 2 minus I. All right, it works. So when I give you a problem tomorrow, I'm going to get it from here. I'm going to choose 4 numbers. 4 numbers that, don't make anything in here excessively difficult or creepy. I'm going to just post them in, and it's going to give me a polynomial, and I just have to be like, okay, I guess so. By the way, this also means I could easily come up with a different one for everybody. So equals rand between -5 and 5, and let me just copy that the whole way down. Wow. Yep, just a whole bunch of polynomials. All right, well, pretty complicated, but I never have to do this hard work ever again.